Hello guys and welcome to today's video. Now today we will be killing two birds with one stone. We will be making a parametric pulley, a parametric timing pulley, and we will be making it into a library part so we can generate as many of them as we want whenever we want them. So a lot of work today. Let's get started. I'll start by making a new part and I'm going to call it GT2 pulley gen, as in generator. I'm going to make a metric 2mm pitch timing pulley. And because this is a standardized part, in order to know what you're drawing, you need some sort of diagram or standard or whatever. And I have this. Okay, so this is a diagram of the belt, not the pulley, right? This is a diagram of the belt, but it has all of the numbers that we want. So we can take every linear value and turn it into a circular one, and we will be fine. So first of all, I'm using Windows Part Toys, amazing software. You should use them if you're not. And I'll hit Control, Windows key, and T to make this always on top. And now if I select anything inside Alibre, this will not go away, right? Because I want to be looking at it as I'm designing. So we have now the diagram, but we said that we're making a part that is going to be ultimately turned into a library part. So it's good practice to start by creating the parameters that you will see when you're generating it out of the library, right? So the first parameter is going to be znum, which is going to be the count of the teeth, right? I'll start with an 18-tooth pulley. Okay, that's that there. Then I'll make a distance parameter. I'm going to call it pulley thick, which is the thickness of the pulley. GT2 belts are usually quarter of an inch wide, so I'll make that 6.5 millimeters. It should be fine again. What else do I want to be controlling? Well, the bore. I'll start with a 6mm bore, and I want to control the keyway. 6mm bore takes a 2x2 key, so the keyway inside the pulley is actually only 1mm. So I'll make this 1. Okay, that's everything I need for now. You'll see that I will be making a parameter, a auxiliary parameter down the line. You'll see that when we get there. So let's start drawing. I'll start a circle on the XY plane, right? And I'll make it into a reference. And this dash dot circle is going to be my dash dot line that you see here in the diagram. Well, what is that? That is the pitch line of the belt. Okay. And if we want to make a circle out of it, what's its length? Well, it's the perimeter of that circle. And it's really easy to find. It's 18 teeth times 2mm of pitch. So the perimeter of this circle is 36mm. But what is its diameter? Well, it's pretty easy to find because the perimeter is the diameter times pi. And that follows that, the diameter is the perimeter divided by pi. So let's go ahead and say that this is znum times 2. Now, if I close this parenthesis, red letters, I'm getting an error. Why is that? This is a diameter. Alibre expects a distance, and I'm giving it a unitless number multiplied by a unitless number. So this is a unitless value. But as soon as I type in 2mm, then this works. So I can now divide this by pi. That's the circle that I want. And incidentally, this value is 11.459, etc. Okay, so that's my pitch circle. But you see that the belt does not rest on the pulley on that line. It rests slightly below that. And helpfully enough, we have this PLD value, which is 0.254. So I'll just make another circle. And I'll say that this difference is 0.254. Now this is the actual outer diameter of my pulley, which I can extrude. Mid-plane extrude. And how thick do I want my pulley? Well, I'll hit the FX button, open the equation editor, and click on the name of the parameter I want to insert, hit OK, and now I've just inserted it. So that's how thick I want it. Cool, we've made the main body of our pulley, but now here comes the really hard part. This is the hardest part of the entire operation. We need to make the opening for the tooth. So I could just project this to sketch because I need this outer perimeter, but in order to make it slightly more robust, I will open the project to sketch dialog, which allows me to project an entire sketch. I want to create reference figures, and I want to maintain association to source. I still want to project the reference figures from this sketch because that will give me the pitch circle. Okay, so let's hit OK. There we go. And I will make a vertical line here, which ends on the outside of the pulley. And I'll make that a reference. So now I'll start with the tooth, right? First, let me say that these belts are slightly elastic. So we will be designing this precisely at nominal dimensions. You don't need to account for any tolerance. Now, I've 3D printed these pulleys and they work like a charm. They work every time, so you don't need to worry about that, right? You just design at nominal and the tooth will work. So, how is this tooth formed? Well, you can see that this is made out of 3 arcs, which blend tangentially into one another, and then the last one is tangent and blends into this flat surface that rests on the pulley. So let's start making this. First, we'll make this bottom arc, this R3 arc. We see that the center is on the pitch line, on the exact center of the tooth. So this is why I drew this vertical line. I'm going to start a center arc, right? And I'll put the center on here and I'll just make a knot. Now you see that I cannot move the center out of this vertical line, and now I will make sometimes doesn't work. So as soon as you put an auxiliary line in there, it will work, and now it'll work like that as well. So I put my arc in, now I need to dimension it, right? So, well, I know that this has a radius of R3, which is 0.555, legendary number 555. And then I can see that the bottom of this arc and the bottom of the tooth has a distance, has a height distance from this surface that the belt rests on the pulley, right? It has a height of right, lowercase h, and that is 0.75 millimeters. So how do I do that? Well, I'll tell it that from this point to the bottom of, from this point to the bottom of this arc, and in this case, what I want is number 2. Yes. So this height is 0.75 millimeters. Now, I could have selected the outer circle and then this, and in this case, I want the dimension number 4, which is the inside slot. Okay, I could have done it like that, 0.75. Okay, now you see that the only thing I can move is the endpoints. Center is fully defined. So I will leave it at that with this arc and go on to the next one. The next one is the hardest one to make. So R2. Well, the problem with R2 is that you see that its center is offset from the center of the tooth, and it is offset by a distance of 0.4. Again, this is the belt. This is a linear diagram. We need to wrap this around the circle. So how do I do that? Well, I will turn this linear distance into an angular distance, into an angle. And how do I do that? Well, so I know that this is 0.4, and I also know that the length of this pitch line is 36 millimeters. So I can find what percentage of the perimeter this 0.4 millimeter is, then multiply it with 360 degrees and get my angle. So that's what I'm going to do. I'll start the line here, make it into a reference line. I'll start my angle dimension, and then I'll hit FX and go into my equation editor. Now, this is the parameter I'm creating, right? A1, but I'm not going to write anything in here just yet. Instead, I'll hit plus, make a scale or percent parameter, and I'm going to call it beta %. Now, the reason I'm doing this is that the equation editor is really particular with dimensionality, and I could have done that all inside the A1 equation box, but it would have needed additional divisions and multiplications to get rid of units and all that, and it's just not worth it, right? So I'll create this separate scale function, which is going to be 0.4, which is the beta value, divided by the perimeter. That's what's going to give me that percentage. And the perimeter is the number of teeth times 2. And that's it. So I hit apply. And I get this value, right? 0.111. So 1.1 repeated %. Now I'll just copy this name. I'll come in here, paste it, multiplication operator, and I will select the number and change it to 360. Now I did all that because I don't want to lose that little circle operator. If you do, you can either say deg, degrees, Alibre is going to know what you're doing, what you mean, or if you're in Windows 10 and above, you can hit the Windows key plus the dot, and you get this menu, and you can go into symbols. Yeah, so you'll find it under general punctuation, and there it is, right? And Alibre is going to know what you're talking about. So as soon as I click somewhere else, this becomes precisely 4 degrees, which is actually the number that I want. And I'll hit OK. And then I'll click this little icon. And now my value has gone in. And if I hover over the equation, it tells me that this is 4 degrees. Okay, so now I have the line on which the center of this arc is going to rest. So I'll start a center arc. And I want this point to be coincident. And I want the 2 to be tangent. Okay. No, kind of like this. And now I'll start dimensioning my arc. Now I know it has a radius of 1 millimeter. And well, that's it basically. The center I located with this angle, and look what happened. As soon as I put the radius in, this became orange, which means the magnet is defined, but the position is not. And Alibre means the position of this endpoint. But the other arc became fully defined, right? So that's cool. Now I know that this needs to end inside the circle because I still have a tangent line to go over there, and I want this to be tangent with the outside of the circle, and I also want it to be tangent with this arc, and I want this to have a radius of 0.15 millimeters. And look, everything is fully defined now. So all I need to do now is mirror these two over. So I will select this, hold shift, and select this, and then click on mirror. And oh, okay, so this only does, so this only mirrors one of it. Okay, anyway. Okay, so this is the profile of the tooth. This is complete, right? All I need to do is cap it with a center arc from the center of the pulley so that I can cut extrude. And we'll cut extrude, tie tab move through all, and this is the cavity of my tooth complete. Now I need to pattern it for how many times? Again, I'll go in here, click on the parameter I want to insert, and it's in there. Yeah, full circle, of course, and the center, I can either choose the z-axis or this outer surface. And this is a parametric pulley now. And we've done most of the heavy lifting. So let's go and make the bore now. And we said that the bore, we have a parameter for it. So I'll just insert it. And this is a 6mm bore. Again, extrude cut through all. There you go. And now I will first make the shield and then the keyway. That helps when we're defining the library part down the line. Okay, so I will make the shield now. I will sketch on this plane. I'll make a circle. I also want to project the circle in as geometry. Okay, so what's the diameter of this circle? Look, I'll reference back to my diagram of the belt here. From the surface that the belt rests on the pulley up to the top of the belt, you have this I parameter for the height, and that is 0.63mm. So I want to say that if I make this, let's see, I'm selecting the top of this ridge, which is circular. So if I make this 1mm, right, that should be plenty. So I'll leave it at that. If you want this to be parametric as you generate the part, you just make a parameter for it and go ahead and control that parametrically. So that's fine. I will extrude this for 1mm. Okay. And then I'll just give it a chamfer of this top surface of 1/8 of a millimeter. Okay. And finally, I'm going to start a mirror. I don't need this diagram anymore. I'm going to start a mirror, and I will mirror this extrusion and this chamfer. And this is my mirror plane. And now I'll go in and sketch my keyway. So I need to project this in as a reference. I will start a rectangle and then make sure both bottom points are coincident to this circle. And I'll start dimensioning this. This is keyway width. And now for the height, I want to select from here to here. And I want number 1 to outside. And this is bore plus the key height. Again, Alibre is not case sensitive when using the parameters. So I can write it like this, and it's going to know what I'm on about. It's just easier on the eye if you do it correctly. So now I'll extrude cut through all. This is my pulley, guys. This is done. Okay. This is completely done. Now just make sure that you make the keyway last. It'll help in the generation of the library part. And let's go do that. So I need to save my part in order for it to be put in the library. And I will add to library, right? So let's make this slightly larger. I get this dialog box, right? Which shows me all of the parameters in the equation editor. And it's asking me which parameters to include into the library part, right? So which parameters are going to be used to create this library part. And I want, of course, I want my Z number, I want my keyway width, I want my bore, I want my keyway height, I want my pulley thickness. I can click on show renamed only, which I should have done. I don't want to bring this parameter in. This is a driven parameter anyway, so I'm fine with this. and I'll hit next. And now I get the most important dialog box in library part definition. So I get the display order, display name, input type, parameter values, parent parameters if there are any, and where does this go into the equation editor, right? Which parameter will this line influence? Okay, so this is correctly selected. Let's discuss this one by one. The display order. That's the order that the user is going to see from top to bottom, and is going to be selecting parameter values. So this needs to make sense. But more than that, if you want to drive certain parameters off of another parameter, the driving parameter needs to be above it in this display order. So I want to drive the keyway parameters off of the bore, right? So I'll make sure that it is above them. I want the number first, the number of teeth first, then I want the bore, then I want the pulley thickness, and then the keyway parameters. Now let's discuss display name. This does not need to be the same as the parameter name. So I can actually write words here. So I can actually say number of teeth, and I can, yeah, this is the bore. I can say this is the pulley thickness, and the user is not going to see these two, so I won't bother. Now input type. Well, this is a numeric user input. Now this will allow the user to input decimal values, and we have a count variable. So in any case, Alibre is going to go towards the nearest integer because it is a count value. So we don't need to bother with this anymore. Bore, numeric user input, can be any distance dimension. Pulley thickness, same thing. Now the keyway width, well, this needs to change according to the bore, right? And how does it change? Well, if we open up a browser and say metric key sizes, Google gives me some results and it says Engineer's Edge, you visit this often. No kidding. So we get this table, which is exactly what I want, right? And you see that we get the shaft diameter, key size, and keyway width and depth, right? So I want the keyway width to be this value, this nominal value, and I want the keyway depth to be this T2 value, and I'll just pick the max values out of here. So I just want to resize this, and I think, yeah, that's fine. So I'll just leave it down here. Have it always on top with the Power Toys. Control Windows and T. If you're not using Power Toys, do download them. So I'll come in here, keyway width, and I will say that this is range driven. This is driven by a range of values. So I'll click to edit, driving parameters. I'll add the bore, and then it says here ranges and resulting values. Okay, so I'll say that 0 through 8, and that's how you define the range. 0-8 or -8, that's a range. The value, and what am I looking at? The width. The width is 2. Tab, space, you add another value. Now, I try not to overlap values here, so I'll just say, right, 1 micrometer. After that, from 8.1 up to 10, this value is 3, and I'll keep going. And that's the keyway width done. Now I will do the same, selecting the values in this column. That's the height done as well. So I've defined everything I want to define here in terms of parameters, but I also want to have a pulley that might not have shields, or might not have a keyway, and I actually made a mistake there. I should have drawn the keyway on the XY plane. I'll show you. If you make a mistake like that, I'll show you how to go back and correct it. So, but in any case, I might not want the shields and I might not want the keyway. So how do I do that? Well, you see here that I have a plus and X buttons. So I'll add a new parameter that wasn't in the equation editor, and I'm going to call it keyway. Basically, that's what I'm going to call it. And now I will select suppression state. So let's click to edit. And when it says with keyway, let me make this larger. Do not suppress any feature. And if it says without keyway, so if the user selects the option without keyway, I want to go, I don't need this anymore. I want to go and suppress extrusion 8. Okay, so that's done. And I'll make another one, and it's going to be called shield. And I'll do the same, with shield. Do not suppress anything. Without shield, this is the interesting part. Okay, so without shield, I want to suppress this extrusion. I'm holding control, this chamfer, and this mirror. And it recognizes that it needs to suppress all three. So I'll hit OK there. Then I'll hit next, and these are the categories. So these are categories, and if you open them, these are part collections, right? So I want to right click here, add a new part collection, and I'll call it pulleys. Okay, select something else that it updates. So this design is going to be stored there, and I'll click finish. So I've made a mistake here, right? And what is the mistake? If we edit this, yes, I've designed this on the shield. That's the mistake I made. I should have designed this on the XY plane, okay? But the point is that now changing anything to this part is not going to make a difference, because as soon as I saved that other one, a new part was made. So in order to make corrections to a part, what you do is you go into your library, manage library, you find the part that you just made, and you hit this little button. It says edit parts library definitions, right? Now, what we want to change is not a library definition, but as soon as I close this, right, I close this, well, I get in my recent parts, I can see the library part. You see, this is a different file path, right, than this one, okay? This one that's stored in the program data, that is the library part. So now I can open it and change its design. So now what I want to do is I want to delete this extrusion and redo it basically. Okay, so now I'll save this. Now I want to open a part or an assembly, go back into my library, manage it again, find my part, because what happened now is I need to reassign that suppression state. Okay, so next, so now I need to go in here in my keyway suppression state, and okay, so it's still extrusion 8. Well, that was fortunate because I changed the last one, right? But I need to make sure that this works. Okay, so now I can input the part, right? So how do I input a part from the library? Well, I either go into a new part and I hit generate, and there's a search function here, and if I search for pulley, it searches inside each category. So it doesn't find one in the fasteners category, but it will find one in my parts catalog category. So yes, this is what I want to insert. I'll hit OK. And okay, here's my pulley, right? It starts with 0 number of teeth. That doesn't work. Let's say I want 36 teeth and a bore of 8 millimeters, right? And as I'm changing these numbers, you can see that this is changing, right? Right. So 36 teeth, a bore of 8 millimeters. If I change this into 13.5, you'll see that the width of the keyway will also change, right? This is now a larger keyway. Let's go back into, let's do it at 10 millimeter. 1, okay. And let's see, do we want a keyway? Let's say that we don't want a keyway. That keyway is now gone. Do we want shields? Let's say that we don't want shields. Okay, the shields are now gone. And we can bring them back if we want to. And we can hit finish. And what happened now is inside the part that we open, we get all of the definition of this pulley. Right? If we had chosen to suppress the keyway and the shields, we would have gotten these features come in but be suppressed. Okay? And another way you could use this is you could add it as a part in assembly. So let's say I'm not going to be inserting any parts here. So when I'm in an assembly and I insert a part, I can search the same way. I want to pulley in my parts catalog. But look, now I get an additional option here. Now I get a file name because it's going to create a file. So I'll call this GT2-Z52 no K, no S. No keys, no shield. So I'll hit OK. And it's as if this is a assembly part, right? And if you're not showing your origin and you want to put it in the origin, you can see down here it's tabbed. So I have the design generator and I can go back into my design explorer and show or hide anything, and then go back into my design generator. So I'll just plonk it here in the center, right? And I can hit finish. So this finish is about inserting copies of it. So I hit finish. I don't want any more copies of that. Cool. So I want 52 teeth and I want a bore of 16 millimeters. And that's the thick, you know what? I want a thickness of 15 millimeters. And I don't want a keyway and I don't want a shield. Finish, right? So this is the part that just got inserted and it has the file name that I told it to, right? Now let's say that I wanted to change some of the parameters there. I just edit this part like it's any other part and I go into my equations and I edit this part. So I can change the bore and I can make it whatever I want. It's just that now these keyway dimensions are not going to be driven by this, okay? But I can still add features to it. So let's say that I want to have a cut 25 millimeters and I want it to go all the way back here and then leave 5 millimeters of material in there. Well, you know what? Let's do 4 millimeters of material. Okay. So let's project these surfaces in. Well, let's actually project this face. Okay, maintain association, and I'll get another line going here in the center. You know, I'm just trying to show you that you can use this as a base and do more design work after the fact, right? Okay, and then let's make the origin coincident with this reference line. And let's have this cut. And then let's pattern that cut for 12 times all around the z-axis. Okay, so this might be the pulley that you want to end up with, right? And instead of doing all of the design work with the cavity and the patterning and whatnot, you can just insert a part that's halfway done, and you know, there you go. You've got your pulley, right? And you can even color it. Look, let's select a color for it. So that's it, guys. Parametric pulley that you select the number of teeth, thickness, and all that, and it adjusts itself to your parameter selections. And not only that, but inside the library part generator. And I hope this was a deeper dive on how the library part definition and generator work, because it's massively powerful stuff. And if you have design expert and you have access to them, you should be using them. I hope you liked it. If you did, hit like and hit subscribe. And I hope I'll see you in the next one.